you can also, like again, look to your table and know that that part is there. There's got to be two parts to this. So again, find your domain restrictions. We factored, and up until today, we couldn't reduce anything. So check your vertical asymptotes, your denominator, same as your restriction right now. Your horizontal, go through your three rules. If the degree in the numerator is one more than the degree in the denominator, you're never going to have a horizontal asymptote, but you will have a slant. Synthetically divided, ignore the remainder. And I like to put this in my Y2. If I put this in my Y2, you could actually see the end behavior happening with your slant. Tomorrow, we're going to be working on taking the parts and creating the function. And putting those parts in that we can really help. So increasing, decreasing. Where?
For the minimum.
8?
Yeah.
8.243?
Yeah, I got something different.
Minimum? Did anybody not get this minimum?
I got that. You're wrong,
Actually, I got 7.447 and then alright, I just want to know why I'm wrong.
Okay, guys, here's the thing, you have to put it back in your calculator.
I did.
And did you do a minimum?
Yeah, I got the same thing.
Okay, let me come check. Let's stay focused. Okay, range. Once you have your Y values in here, then do your range. Oops. Okay, so that happened weird again. So now, your range, you do it towards the end because you have to find your max and your minimums first. So your Y is traveling all the way up here from negative infinity, stopping at that relative max Y point. Then it jumps over and restarts at this Y point to infinity. You're not going to be able to find your range usually till the end. And today, too, when we throw a point of discontinuity, we need to find that before we can find the range. So do the domain. Always do your domain first, because those are where your restrictions are. Everybody okay with the increasing, decreasing concavities? Okay. All right. Nope, not that one. This one was just a regular one, which we drove actually crazy over. This one was a regular one. Find your domain. This one was kind of straightforward. Y-intercept is nice. There were no zeros, and you can see by there's no zeros in your numerator, no variable in your numerator. Concavities, everybody okay with this? Range good? Increasing, decreasing? Okay. They're both decreasing segments. Good? Okay. All right. Another slant one we had. Again, you should find, this is the one we did in class, right? Yes. Okay, we did this one in class. I had changed my class one and I forgot, because I wanted to make it easy. Guys, stop talking. I wanted to make it easy when we did the max and mins in class so that everything kind of worked out with regular numbers, so that everybody wasn't trying to find them in the calculator, and I forgot to take it off of this. I was going to put my sample one in this one, and I didn't. So you got lucky. All right, last one. Again, you're going to have to adjust your screen. When you don't see these things, be careful, because there's always got to be another part with the slant asymptote. So in this case, you're probably only seeing this one, and you're not seeing this one. Look at your table. Look to the left of -2. -2 should say error. You have values in Y out there, but you didn't see this part because it didn't go low enough. So you're going to have to change your screen because you have to do your max. You have to do your max and your min. So you're going to have to adjust your screen. Again, these are relatives. Make sure you use relative instead of just max and min. Concavities works nice here. Increasing, decreasing, go back to your max and your mins. Everybody find the slant asymptote? Put it in your calculator. You put it in Y2 so that you can see it.
For the increasing, what's that first thing with the negative?
Negative infinity.
Okay, good.
Um,
That's fine.
I'm not a good infinity maker. Good? Again, factor again. So you have an x of 0, an x of 3, and an x of negative 2. And you can clearly see, you saw your asymptote at negative 2. You saw your asymptote come through. Your asymptote came through. That's what caused this little problem over here. This is in the wrong spot. But that's what caused this little problem here and that one to go over here. And you can see at the 0, we have another one that caused that little thing up there. But the 3, you can't really see. Because on some of your calculators, you have ends. But some of them, they'll be a little bit more exact. You can see that it'll pass over. It'll look like a regular graph. This is the point of discontinuity. It's just a little point. And if you look in your table, it'll say error at the 0, error at the 3, and error at the negative 2. But it doesn't affect the end behavior. It doesn't give us an asymptote. It's going to be a point that we can remove. So now, keep your factors down here. And factor the numerator for me. What factors do you get in your numerator?
X minus 3 and X minus 2.
Okay, so now, huh? What? All right, so now, we're going to factor and reduce this. But you're going to keep track of the point that you reduce. What can be reduced? What factor can we reduce? X minus 3 can be reduced. We're going to circle this. Circle this and bring this over to the side. And write point of discontinuity. Just put that over to the side, and we'll come back to this. What's left in this, we put down what's left. Okay. Now, our point of discontinuity we're going to return to in a minute. We're going to do everything else the same way that we did. We have your x-intercepts. Your x-intercepts are zeros of your numerator after we factored. So we're left with x minus 2. And yeah, we can see that that one crossed over here. There was your 2. It crossed over it. Okay? Y-intercept, we should do the y-intercept right off your original. Get rid of all your x's, and what's your y-intercept going to be? 6 divided by 0 is no y-intercept, right? All these are going to come out. Those are going to come out. You're going to be left with 6 divided by 0. No y-intercept. And refer to your graph. Do you see your graph touch your y-axis at all? Because what we're going to see in a second, that's where your asymptote is. So now, let's work at your vertical asymptotes. After you have factored, after factoring, go to your denominator. These are the zeros of your denominator after factoring. After factoring and reducing. So we've got x equals 0 and x plus 2 equals 0. So here's where your graph is. There's your asymptote right along your x equals 0. That's why you don't have a y-intercept.
And the y-intercept is at 6/2.
6 over 0.
Alright.
6 over 0, so we have no y-intercept. And look why. Our asymptote is on the y-axis. It's x equals 0. Our other one is x equals -2. That's going to help your n behave. Now let's do your horizontal asymptote. Your horizontal asymptote says when the degree in the numerator, the highest degree in the numerator, is less than the highest degree in the denominator, what's your asymptote? Y equals 0. So here's another asymptote right here. So that explains this guy's end behavior for me here. This one is behaving within these two vertical asymptotes, but this one misbehaved a little bit. He jumped over the horizontal asymptote. But once this one jumps over the asymptote, it still rides right alongside of that asymptote. It still is there to do the end, to guide its end behavior. Unfortunately, your calculators don't do a really great job when it gets close to the axis because it can't graph it that close. And if you look at your table, you'll see they're really small numbers. Your calculator just kind of looks like it ends things off. But you've seen that before in your calculator. All right, so let's return back to your point of discontinuity. So let's solve this. X equals 3 is where I have a point that I have to jump over. If I could fill that in, if I could approach that from both sides, this is where the limits come in. I would want to know what would that y value be. Algebraically, we take what we reduce, we take this, and we plug in the 3. We just substitute in 3 into your reduced one. If you plug it into your original one, it doesn't work because 3 wasn't removed from your original one. So if you plug it into this one, you get 3 minus 1 over 3 times 3 plus 2.
You plug it into the reduced equation?
You have to, because if you plugged it into your original one, it would come out undefined. Yeah, because there's no place for that really, but we're going to remove this point. It's called a removable point. When we look at in calculus, we call this a removable point. I'm going to show you in your calculator also. 3 minus 2, sorry. So put this in, figure this out, and what's your y equal to now? 1/5. So here is your, was it 1/5? 15. Here is your removable point. This is your point of discontinuity. When we ask for a point, we need it to be an xy. Now, in your graph, in your table, you're not going to see this. But go to your graph for a second and do this. Second calc value. Put in x as 2.999. I can't find 3. 3 will be blank. What does 2.999 say? 0.06. Okay, just keep track of that guy. Put in 3.0001. Close enough, right? 0.06, blah, blah, blah.
Yeah, it's a little different, but it's still...
Close enough. Do 1 divided by 15. Doesn't that show you that that's right where it would be? If in fact I could remove it, if in fact I could fill it in, doesn't that show you 1 divided by 15 is real close to what you got here? That's why we're able to remove this point. This here, an asymptote, we can't remove it. And when we get to calculus, there's a jump discontinuity. It has to miss this. It can't go, it guides your end behaviors. We can't cross this. This is a good example too. You could see that this actually crosses your horizontal axis. Now there's another problem. Because it crosses your horizontal axis, it goes slightly up and then back down. This guy has a maximum in here. This has a relative maximum in here. See if you can find your relative maximum. We've got a relative maximum and we have one other thing to find too. See if you can find your relative maximum. You should be able to do a max right on there. It's within your 10 by 10. Your calculator actually will find it.
I think I did it already. You know what?
It should be in the fours.
I got 4.828.
Yep.
And 0.085. Or
Good.
0.086.
Six. This is your relative maximum. You've got a point of discontinuity. Actually, our point of discontinuity came before it, and then came our relative maximum, and then it guided your end behavior. Unfortunately, we got to take that into account because now we have a concavity in here, and we have a max and a min. We have an increasing, decreasing. Go do this on your calculator. Go second calc, max, and do from, what's this guy, 0 to 6, to 10 to 6.
I just did 10
To 10 because it's the end of the screen. Do it this way because you're probably too close on the line there. So give it an endpoints with your numbers. You can always give your boundaries with your numbers.
Just like instead of using little arrows, just
Don't
like
use the
this
arrow.
left bound, just hit 0.
Hit 0. Hit 0 like 0 to 10. 0 to 6.
When it says right down, hit 10, enter, and then 0 again.
You guys never did that last year? With the maximum in? And then you'll get exactly it. It's sometimes hard because your calculator's not showing great lines. The newer calculators, does yours get closer to the line down? Or it ends like kind of sitting there too? I thought the newer ones did a better job. Yeah, you see yours is riding along your axis? Yeah, it is. The new ones do a nicer job with it. Because of the color, like the old ones, it's on black, so you can't see it, but the new ones with the color, you can actually see the line go through. Yeah.
Do we have to
Okay.
find the minimum of that little parabola?
Uh-huh. We have is this an absolute, guys, or a relative minimum?
Relative.
Relative minimum. Find me your relative min. You're within a 10 by 10, so you should be fine.
But will it
Go
calculate
between
the
-2
minimum?
and 0.
Oh.
You got two asymptotes. It's right between your two asymptotes, right? Between -2 and 0. And your relative min should be this. Got it now? So now we should have all the parts that we need. The little guy on the left-hand side has no max or min because it's a smooth increasing, decreasing type thing. Let's see if we can find a range. So what do you think the range goes to? Negative infinity to something. To where? Here, look, here it comes. It's coming up here. Uh-oh, it got stuck at that point of discontinuity. There is no point there. It's open. So what's the y value of this point?
Wait, what are we trying to find?
Range. Guys, stay with me.
Well, I was writing.
It would have stopped here at the 0, but this guy crossed over this axis. So it came up here, it said, whoops, you have an open point here. You can't use that x, you can't use that y. So what was the y value that we found for that point of discontinuity? 115.
So you wouldn't count 0?
Well, you don't, because this one went through the 0, so there is a 0 out there. One of your zeros was at 2. That was the 0 that we found.
Okay.
We went through that. Sometimes it goes through a horizontal. Sometimes it acts nicely. You can't go through a vertical.
Okay, that's right.
You can go through a slant and you can go through a horizontal, but not a vertical, because where does your verticals come from? Denominator. So you can never go through a vertical. So from negative infinity to 115. Okay? Then we went from 1/15 to where? Over here. Ah, for the highest part of this, 0.086. And if you want to leave me a fraction or a decimal in there because we're kind of mixing them up, you can gladly do that. And then we have another section. Where's our other section? We got to start back up here. We got a lot going on in this one. Okay, let's stop a second. It's long, because you got to jump over that point. And generally, we only make it where you have 1 point. You don't have more than 1 point. So now, this guy right here, isn't this a concave down?
Yeah.
Okay, so we're concaving down from where?
Negative infinity to negative 2.
Okay, what's this guy doing?
Concaving up.
Concaving up from where to where?
2 to 0.
Everybody with us here? Okay, concave down. This made it down. Yeah, we talked about this the other day. Even though it doesn't exactly look like it's turning all the way back around, we considered it a concavity in this part. So this is concaving down, if you will. This guy here, clearly a cave up. This guy, what would we consider this? A concave down. However,
It's from 0
you got to
to 3.
jump over here. So from 0 to 3,
And then from 3 to
and then from 3 to infinity. You just got to jump over the point that you can't use. Yes.
For the increasing, why is it negative 0.828 and 0? That was 0.
Okay, but wait. Tell me where you are.
Top increasing, the first one.
Increasing. So we started at, this was a decreasing, this was a decreasing, this was our first segment of increasing.
Oh.
So we look at that relative minimum x value, right? And from that x value till we hit the wall, till we hit the 0.
Okay.
Okay? The key to this, guys, is you seriously have to wait for